Here we have another question of partial fractions. The integral is 3x squared minus x plus 8 divided by x times x squared plus 4. First step is to write that as a partial fractions. For that, we need to notice that we have denominator, which is one linear factor, non-repeating because power is 1, and one quadratic irreducible factors. So for the x, one linear factor, there will be one fraction with a as a constant, plus for the quadratic factor though, the numerator would be some linear factor because we cannot factor this quadratic factor any further. Try to make the common denominator. That's multiplying the denominators. A will have to be multiplied with x squared plus 4 plus bx plus c will have to be multiplied with x. Because we know these two fractions should be equal to each other and their denominators are same, therefore their numerators should be same. So we can say 3x squared minus x plus 8 should be equal to a times x squared plus 4 plus bx plus c times x. We are claiming this should be true for all x, therefore it should be true for x equal to 0. X equal to 0 I got from one of the factors. I'm going to put 0 here. So 0 minus 0 plus 8 is 8 equal to 8 times 0 plus 4, and this whole thing will just turn 0. So what do we have? 4a is equal to 8. That is going to give me a is equal to 2. So I found my first value, a is equal to 2. So I can't find another value of x from the second factor because that's irreducible. So I can pick any x value basically. So let's try x equal to 1. Okay, if I put 1, this would be 3 minus 1 plus 8 equal to a times 1 plus 4 plus b plus c times 1. Okay, that is going to give me 3 minus 1 is 2 plus 8, 10 equal to 5a. A is 2 plus b plus c, I don't know, right? So this is 10. 10 minus 10 is 0. Therefore, b plus c equal to 0. Okay. So we didn't find b or c from here. So we need another x value. Let's use x as, we can pick any number, but pick something which is easier to handle. Let's pick -1. When I put -1 in the same equation one more time, 3 times -1 squared plus 1 plus 8 equal to a times -1 plus square plus 4 is 5 plus negative b plus c times -1. Okay, what do we have? 3 plus 1 plus 8 is 12. We know a is 2, so 2 times 5 is 10. And this will be plus b minus c. Therefore, b minus c, subtracting 10 on both sides, is equal to 2. And from here, we know that b plus c is equal to 0. If I add these two equations, what do I get? 2b, because c will just cancel, is equal to what? 2. b is equal to 1. So this gives me b is equal to 1. And because b plus c is equal to 0, b is 1. Therefore, c equal to -1. So I found all three constants which are required to write partial fractions. So using a, b, c and my assumption of the partial fractions, I can say my given integral can be written as a by x. A is 2 by x plus b is 1. So x minus c is -1 divided by x squared plus 4 dx. So using all that partial fractions thing, right, we got this integral which is easier to solve than the original integral. So now we just need to solve this integral. Let's solve this integral now. We can split it up. Integral of the first one. This also we can separate them out like this. X by x squared plus 4 with respect to x minus integral 1 by x squared plus 4 dx. Okay, the first one is straight formula. The answer to that is 2 times natural log of x plus the last one is also a straightforward formula, but that is tangent inverse of x by 2 because this is 2 square. So x by with 1 by 2 outside plus c. The only problem is we don't have a straight formula from this second integral. So what I'm going to do is use substitution for this one. Let's put u is equal to x squared plus 4. Du would be 2x dx. X dx is already in the question. X dx is equal to du half. Therefore, my integral is half du 1 by u, right? Now we can solve that easily. The first one is already done. 2 natural log of x plus half natural log of u minus half tangent inverse of x by 2 plus c. We are almost done. 2 natural log of x plus half natural log of, in place of u, what can we write? X squared plus 4 minus half tangent inverse x by 2 plus c. So this is your answer for the original integral.